Okay, we're back. Oh yeah, the end of the video, I gave you guys a riddle. Paris starts with a P and ends with an E. Is that true? Yes, it is true. Paris starts with a P and starts with an E. There's your riddle. There's your answer. Okay, well let's go ahead and move on here. We just found the intersection points, which usually doesn't take very long. The explanation takes a lot longer than actually finding these points. So let's look at this diagram. Let's figure out what's going on. We've got this region here, the solid region that you see. It's going to be rotated around the line y equals -2. So I'm always going to draw the line of rotation, or the axis of rotation, as an orange line, so you can be consistent about that. And if you can visualize this, if you remember the pair that we saw in the first video, we've got a if this in fact were a solid figure, in other words, if the curve, the solid region, went all the way down to the line of rotation, then we wouldn't have a hole. But if you can visualize this region here being rotated around that orange line all the way back around, there's a big huge hole in the middle. It does form a three-dimensional object, but there is a big hole in the middle. And so the idea here, we're going to calculate the volume of the entire region as if there were no hole, and that would be the volume of the red disks. Okay, and then we're going to subtract from that the volume of the hole, which would be the volume of the green disks. So if you can see this, let's do this first. If we're going to try to find the volume of this solid as if there were no hole, then we would produce that one disk here that has a radius right there. So the radius goes from the purple curve, which is the curve y equals the square root of x plus 2, all the way down to the line y equals, where's my orange? Y equals -2. Okay? So that means that we know the volume red, so we go volume red, is equal to the integral from a to b. And this is where, again, now I don't have to write the numbers down because we already stored those values. The volume from a to b of the volume of one disk. So again, if this were all solid, we'd be finding the volume red from a to b. The volume of one disk is pi times the radius squared. Okay? Well, we know the radius, we know how to find the radius. And so let's put the pi in there, and let's put in the radius. Now the radius, then, if you look at this figure, is the distance from the top of the red disk down all the way down to the axis of rotation. Okay? And they're the line of rotation, whatever you want to call it, but that is the radius red, okay, as if there's no hole. Now that radius is the length of that line segment, is this curve here, the purple curve, which would be radical x plus 2, okay, we're going to have to square that, radical x plus 2 minus, I didn't leave much room, sorry, minus that line right there, and that line right there is y equals -2. So we're going to subtract -2, and since I don't have much room, I'm going to change that subtract to a plus, and I'm going to make that a plus 2. So minus -2 means plus 2, and squared. So that right there, and I'm going to try to be consistent here, that's going to be our big radius. Radius red. Okay? So the volume red, we can easily find that. Oh, pi r squared, and don't forget that thickness of the disk is our dx. Okay, don't forget we are evaluating this integral from left to right, so yeah, that's going to be a dx, and then our integrand is with respect to x. Okay, so then again the concept is find the volume of the outside, which is the volume of the red disks, and we're going to subtract the volume of the green disks. So we're going to go calculate volume green. Okay, that's again the volume of the hole. And the volume of the hole is, if you look at the the blue curve, y equals e to the x. From that curve all the way down to the line of rotation, or the axis of rotation, we have a radius. Okay, and so the volume of the green discs, or all the green discs added up, is the integral from a to b of pi r squared. We're going to add up an infinite number of volumes of green discs. Okay, and it goes from a to b, integrate from a to b, pi times, now the radius of the green discs, or one green disc radius, would be the distance from the curve, which is the blue curve now. This is the bottom one. Okay, the blue curve is e to the x minus -2. And we're going to square that. So the radius, pi r squared, so radius is e to the x minus -2 squared. And then we have to multiply the pi r squared by the thickness of the disk, and that's our dx. Okay, and so let's clean that up just a little bit. And we have a to b, pi times e to the x plus 2 quantity squared dx. Now the tricky part is to type this into the calculator, because now we know what we're trying to find, and let me write that in black. And we're going to write total volume. Total volume equals volume red minus volume green. So volume red minus volume green. Okay, so let's go ahead and do that on the calculator. See, before we actually do that, where's my black? Okay, before we actually do that, I'm going to help you out on the calculator a little bit. Radius red and radius green. Let me do that first. This is radius, now little r, so the book refers to the radius of the hole as little r. Radius green. Okay, so we have a big R and little r, and we'll try to graduate to that equation, but you have to understand how to get the equation. So volume red minus volume green, this is like the volume of the pear without the hole minus the volume of that part that we took out of the pear. Okay, gives us total volume of this region, of this solid. Now again, like I said, I'm going to help you out here with this part right here. In order to really make less mistakes, what you want to do is you want to make this the volume of your red disk, your Y3. So if you can type that in as your Y3, you're going to be a lot better off. And then your volume of the integrand here, let's see, this integrand right here, that's going to be your Y4. Okay, so let's go ahead and do that. So your Y1, Y2, and your Y3. So again, your Y3 is going to be your pi multiplied by the radical x plus 2. And you can see that's your Y1, so if you wanted to do that, you could. I'm going to try to, sorry, x plus 2, x plus 2. And that, we're going to add 2 to that. Okay, and that whole thing, we're going to square it. Okay, so if you do that, you're going to make way less mistakes, because students always forget the pi, and then they always forget the squared as well. So the Y4, we said that was going to be your pi multiplied by e to the x plus 2 squared. Double check that you have each one squared, compare it against what you have written down on your paper. Okay, and then quit that. I know you guys don't like to go through this much detail, I know that, but I looked at your quizzes the other day, the lesson quiz from 7.3 Part 1, and you guys are making careless errors because you weren't showing all your work. Okay, and so let's see, total volume equals volume red. from A to B. I'm not going to put the boxes around it anymore. y3, and then minus, okay, the integral from A to B of y4. I guess you can put a dx on there, and you put a dx there. So let's go ahead and calculate that. Type that into your calculator, see if you get the same answer that I do. Okay. Going to go math 9. We're going to go alpha A, alpha B. That's your y3. Ah, blew it. Calculate, forgot the dx. And you should get that for your volume red. Okay. And just so you can troubleshoot if by chance you don't get the right answer. I'm going to subtract from that math 9, alpha A, alpha B, limits of integration, vars, y variables, 4, y4, dx, and we should get 19.725. Okay, so there's your volume, 19.725. Okay, let's write that down. 19.725. Okay, new riddle. Well, I'm putting a box around this. What 11-letter word is pronounced incorrectly by more than 99% of Ivy League graduates? What 11-letter word is pronounced incorrectly by more than 99% of Ivy League graduates?